So, I want to demonstrate this project, and I remember we got stuck last time. You're going to need the malware samples, and last time I unzipped them, but I couldn't run this executable, because what happened, I think, is it pops up a box saying, "I've protected your PC," but maybe not. I'm going to right-click, open, there we go. And yeah, it looks like it's still refusing to run. Wait, now here it comes. Good. There we go. And it says accept the license agreement. And there it goes. So it's going to put them in there, so I will extract. Anyway, before it popped up like a smart screen, and all you had to do was click more info to make it go past that. It didn't do it to me this time. It just made me wait a while. I'm going to decline. All right, so I've unzipped the things. Here's the labs. So in here, the binary collection by different chapters. And if you go to chapter 1, there's a few pieces of malware in here, Labo 101, Labo 102, and so on. All right, so here, the first one we're going to do in 101 is send it up to VirusTotal. So here's VirusTotal, and you can upload a file. As I mentioned, this is not very good OPSEC. If you upload a file here, you might alert the bad guy that you're on to them, but in our case, we don't care. So I'm going to upload lab101.dil, okay? lab101.dil. There we go. And so it recognizes it, 43 vendors flagged it as malicious. It gives you a hash value of it. And as I said before, here it shows you which people identified it as unsafe. And it gives you details here showing basic property like the hash value and the history and what compiler was used. And here's the sections, text, R data, data, and relocation. Here's the imports. You can see the functions it used and so on. So, you know, it's really pretty nice. And sometimes they run it in a sandbox and you get dynamic information, which I think we'll have here, behavior. Yep, sandbox reports. So it has been run. Here's network communication. Here's the network ports it makes. Here's registry keys it changes. Here's processes it terminates, processes it launches. Mutex is created. We'll talk about these later. Mutexes are handles in memory that can be seen by other processes. There are signals available to other processes. And here's the libraries it loaded. Here's some of the functions it called, and so on. So it's really pretty nice. Does a lot of nice analysis for us free on VirusTotal.
That sandbox report is run by somebody else, not the one that you loaded up?
Yeah, it's run by, I think, Joe Sandbox or something. There's commercial products that I think are cooperating with it.
Initiated by somebody else, run it by somebody else.
Yeah, not me.
No, they put on the sandbox, right?
Yeah.
To run the virus.
Yeah.
That running process is initiated by somebody else, not you load up the virus into running.
Well, they do it at VirusTotal. So somewhere at VirusTotal, somewhere on Google servers, they spin up a machine and run the malware and get a report, and then they add it here.
Not the user control running.
No. There are some sandboxes that will let you upload a file and control the running, but not this one. This one just lets you see a report, which probably is from years ago. So they ran it in some tool. Yeah, a good point. All right. And by the way, there's a community tab that will show you like what people say about this file. Various people saying things. Anyway. All right. So that's VirusTotal. If you have malware that's actually known malware, of course, that's very easy. However, typically you won't. And so now you can examine it yourself. So PEView is going to let us see what's in that file. And you can install these tools one by one. That's what I've done. And I should mention, by the way, that if you're running on a Mac M1, you will not be able to do the debugging projects. So you'll have to use a cloud machine for that. The projects for today will work, but the debugging projects aren't going to work because you don't have the expected assembly code there. You've got ARM assembly code. Everything will look different, and you'll need to use different debuggers for that. And we're analyzing x86 malware. So we're not going to be analyzing ARM malware in this class, not yet. So let me launch PEView.
So if you run on the regular PC, you got the PC code, right?
You can run PC programs on ARM because they make API calls to Windows, but the underlying assembly code is different. And when you run it through a debugger, it won't look the same. And in fact, the debuggers won't run on the wrong hardware.
If you run it on a regular PC, Intel PC, it will show up the Intel assembly code, right?
Yes. So you'll have to use an Intel-based machine, either locally or in the cloud. So for people with a Mac M1 like me, I'll use an Azure machine probably. So this is PE View, and it can open anything, and the thing I'm supposed to open is lab101.exe, I think, yep, okay. So that is in my downloads folder. C, users, SAM, downloads, practical malware analysis labs, binary collection, chapter 1, lab101.exe, there we go. All right, so this is what it looks like in PE View, and I think I can probably make that font a little bigger. Let me see. Yeah, font, good. I'll make it bold and a little bigger. All right. So here, at start, you just see a plain hex view of the file. This is the whole file in hexadecimal, so you see the bits, and on the right is the readable text if there is any, and a dot if those characters are unprintable. So here you have the boilerplate you'll see at the beginning of every executable, NZ, and this program cannot be run in DOS mode. And then down here is the start of the portable executable header. This is the old MS-DOS stub from an ancient version of Windows operating system that's not in use anymore. This is the modern one, the portable executable header. And in there, you have some information. You see information about the sections, text, data, R data, .text, .r data, .data, these information about the sections. If you scroll down, you'll see more and more stuff, including stuff here. This looks like assembly code. And eventually there'll be readable stuff. These are library calls. These are things like find next file A, find first file A. Those are the names of Windows API calls, and so on. That's one way to view the program. But here, it breaks it up into meaningful sections for you. So that's the DOS header, like I say, from Microsoft's MS-DOS, its long abandoned operating system. Not interesting. Here's the part of it, the stub program. And here's the NT headers, which are what really matters these days, starting with PE for portable executable. And if you expand it, there's a signature, which is PE, and there's an image file header that tells you information like a time date stamp. Here's the time it was compiled in 2019. And then an optional header with more information about the size of the segments on disk and in memory. And down here are some section headers for these things, and here's the actual sections themselves. So here's the text section, which is not readable text, it is assembly code. So it looks like just random bytes. Here's the R data section, which has got imports and export tables, which are what these functions are. If you expand it, yeah, here's the import address table down here. It's showing you all the functions it uses in all the libraries. And down here is the data section, and that's going to include strings it uses. And notice, by the way, there's kernel32.dil and there is kernel132.dil. So that's a suspicious thing right there. This strongly suggests that it creates a file that is intended to look like kernel.dil, but isn't really kernel.dil. This is a common trick malware does. They make a file that looks like, here's a warning, this will destroy your machine. This is where strings and messages are stored. So that's the kind of thing you can get from PE View. Get an overview of it, and there's a flag defined in there. All right, and then there's PEID. PEID is an interesting program. PEID tries to figure out what language the program is written in. So I'm going to close PE View and open PEID. It just uses a whole long list of signatures for various languages. All right, and now I open the file here, and that will be, again, it defaults to somewhere stupid, C, users, SAM, downloads, malware analysis labs, chapter 1, and again, I want lab101.exe, which is this one. All right. And so now you see a summary here. This program is written in Microsoft Visual C++. And here's the sections. There's a text, R data, and data section. And there's the first few bytes of it. And that's really about all we're going to use this for. We're going to use it to identify packers later. But that's the start there. So there's another flag defined there. And now there's bin text, which people are talking about, good, clean fun. Bin text is a graphical version of strings. You can do it all in the command line with strings, but bin text is a fun graphic tool to make it easier. So we're going to open labo101.exe. So it's browse, and like everything, it opens somewhere stupid, and I have to do all this nonsense again. C user Sam downloads. Practical Malware Analysis Labs. Chapter 1, labo101.exe. All right. And then go. And what it does is it just finds all readable strings, just any series of printable characters greater than a certain length, which you can adjust. I think it's like 5 characters. And it shows you where they are. And here they are just in the order in which they are found. So here's this program cannot be run in DOS mode, which is the start of every file. Here's the headers, text, R data, and such. Here's the import table with the name of files. So you're just seeing all the readable strings. The great thing about this is it's easy to understand. You see things, and often you can figure out what's going on without doing anything more complicated than just reading the readable text. So here's a bunch of low-level function calls, and here's those things we saw before, Kearney 132 and C Windows System Kearney 132. So now we have a pretty good idea exactly where it's going to hide this malicious file on your machine. So there you go. And I think down later you're going to see like an IP address. Maybe not this one. No, all right, this one doesn't have an IP address, but you see what's going on there. It's pretty good. Strings is fast and easy. Of course, you're not really proving that it's calling those functions. It just has the name in there, but usually that's good enough. And so if you look at the DIL file, labo101.dil in bin text, which is the library used by that same piece of malware, it has an exe file and a DIL file that comes in with it. So let me bring that up. I think that's where we're going to find the IP address. At least now I finally remembered what folder I was in. I appreciate that. labo101.dil. And go. All right. Again, the libraries also have to have this MS-DOS header. Here it's got the import table with functions it's going to call. More functions it's calling. And there's an IP address looking thing. And then it calls sleep and hello and so on. So, you know, get some idea of what it's doing. It's calling WS232, which is networking. I think it's networking, WS2. Yeah, WinSock. And here it is with an IP address. So it's doing that's some clues. All right. All right. And again, there's more flags to find. And then we can use Dependency Walker. I think I've installed that on this machine too. Depends. I think that's it. Depends. And I want to see labo101.exe. All right. So it's open. List labs. All right. Oh my. Errors were detected when processing it. Maybe it doesn't run well on the ARM. Oh, it looks like it worked. Error opening file, system cannot find the file specified. Well, not terrible. I see some libraries there. Here's labo101 calling the libraries. So, seems to have worked to some extent. I'd like to make it bigger. There we go. All right, let's take a look here. So the executable uses only a small number of library functions. One of them is string comparison. So let's try that. That's an msvcrt.dil. labo101.exe, kernel. MSV CRT, there it is. So I click on that, then over here I will see the functions it uses, and you'll see it only uses a small number of functions. You see the scroll bar there, and here's string compare, exit and malloc. So it's a very simple program, not using very many functions. If we analyze the DIL, we'll find the low-level BSD calls for networking. So let's try that. lab101.dil. All right. It's thinking about it. And now it's going to complain, but I don't care. All right. And now I want to look at the calls for WinSock2, WS2, so not kernel, but WS232.dil. Here we go. And now, here you'll see what I mentioned before. These are the BRAW sockets invented by Berkeley Standard Unix: accept, bind, close socket, connect, get peer name, and so on. These are the basic low-level calls that made the internet. This is the basic level calls to peak TCP/IP, and that's what's all used for all networking, but you don't normally use this library where you have to use these low-level calls. You use a high-level library like WinINet that does it for you. And so there are more flags to find here using these tools, and that's the main thing. That's the first project I wanted to show you here, where you start using these tools. Let me go to stop the recording.